Good morning, everyone. Happy Monday, May 4th. So first and foremost, may the 4th be with you. And today in science, we are going to be talking about continuing our discussion on human impacts on the environment. Last week it was desertification, deforestation. This week it's going to be acid rain and ozone depletion. Your only homework for today, please submit a picture of the notes that you take during this video lecture to count as your homework assignment. So let's jump right into the first, which is acid rain. Now, before we talk about how acid rain forms, I just want to give you a little background on the pH scale. Acidity, or the opposite of acidity known as alkalinity, is really a measure of where a substance lies on a pH scale. The pH scale, again, just measures acidity or alkalinity. Now, the lower the number, the more acidic the substance. So as we move in this direction, we get stronger and stronger acid. Battery acid has a pH of 0, our stomach acid has a pH of 1, etc. Right in the middle, okay, a pH of 7 would be pure water. Very little water is actually 100% pure, but if it was just H2O and nothing else, it would have a pH of 7. As we move in this direction, okay, higher than 7, we start getting more alkaline, or sometimes we say basic, okay, because the opposite of an acid is a base. Now, some of the most basic substances or alkaline substances that we know of would be bleach or drain cleaner. This is sodium hydroxide. Even our blood is actually a little bit alkaline, okay? We don't want it to be higher than 7, really. We don't want to have a higher pH. One important thing, it's very important that you understand this. The pH scale is a logarithmic scale. What that means is, for every step that I take in this direction, I'm not just getting, 2 times or 1 times more acidic. I'm getting 10 times more acidic. So milk is 10 times more acidic than water. Coffee, which is 2 steps over, is 100 times more acidic than water. So as we move up to these really low numbers, you can see this is drastically more acidic than straight fresh water, pure water. Same thing occurs over here. So the logarithmic scale means for every step that we take, this is 10 times greater, another 10 times, so 100, 1,000, etc. That's going to be important because acid rain, the pH does not seem that drastically different than regular rain, but when we keep in mind that it's a logarithmic scale, it's 10 to 20 times more acidic. So what is acid rain? Acid rain really is any type of precipitation, so it's not limited to rain, that's made acidic by atmospheric pollution. It can also occur as dry deposition, as these pollution particles kind of cling to buildings and then later react with water vapor in the air. Either way, though, no matter how it occurs, it's going to cause harm to the ecosystems, all of our infrastructure, so our buildings, bridges, etc., and it does actually impact human health. The number one cause of acid rain is the burning of fossil fuels, and we talked about way back in the fall, early winter, our renewable versus non-renewable resources. So we're obviously talking about our non-renewable resources that we burn in industry and travel. Acid rain typically has a pH of about 4. Typical rain is going to have a pH of about 5 to 5.5. So we're talking about 10 times more acidic because remember, it's that logarithmic scale. Important to note, regular rain, okay, it does have an acidic pH because there are natural sources of some of these gases that cause acid rain, like volcanoes and things like that, even lightning. So regular rain does not have a pH of 7, okay? But acid rain is even more acidic than that. How does it form though? Okay, so how does this pollution cause acid rain to form? There are 2 main pollutants that we're looking at: sulfur dioxide, SO2, and nitrogen oxides, NOx. And the reason we have the X here, it's for the same reason you have an X sometimes in algebra. It's a variable. There are many different kinds of nitrogen oxides, so we just kind of put this X and that encompasses all of them. These 2 gases combine with water vapor in the air to form 2 very strong acids, sulfuric acid and nitric acid. Here's kind of a diagram of that process. So here's all our air pollution going up into the clouds. We can have just dry deposition. We can have acid snow, acid rain. Here's our chemical equation for what's actually happening. So it's a fairly simple reaction. And here's just a table of all the possible nitrogen oxides. So as you can see, there's a lot of different ones. That's why we just put NOx, okay? And if you're wondering what are the main sources of these 2 acid rain causing gases, for sulfur dioxide, mostly electricity generation. So we talked about how most of our electricity comes from fossil fuel burning power plants. That's the primary source of releasing this particular pollutant. For nitrogen oxides, it's not electrical generation. It's some, but it's mostly our vehicles. Okay, so mostly what's coming out the tailpipe of all of our cars. Now, fortunately, most industries use technology to decrease, but they can't completely eliminate emissions from smokestacks. So here is an example of a smokestack that is not using any sort of technology to get rid of the SO2 and NOx. This one is. And this one, thankfully, looks a lot like the ones I see in our area. What's coming out here, the smokestack, it's not smoke, it's actually just water vapor. They're using what we call a scrubber system. A scrubber system, instead of just spewing out the sulfur dioxide and the nitrogen oxides, they actually, as it rises through the smokestack, spray water on it. So they kind of get it to react before and join up with the water before it is released into the atmosphere. So those particles kind of cling to the water vapor, and then that water collects down here as sludge water. They call that scrubbing because we're actually kind of cleaning or scrubbing that air before it goes out. And then we dispose of the sludge in a way that's much more environmentally friendly. Automakers, so if we're talking about nitrogen oxides, they have strict emission standards. I know you guys don't drive yet, you will be soon. And when you get your car inspected each year, you have to pass an emissions test. And it's not cheap really to pay for it. But the emission test is really just making sure that you are within the permitted limits of nitrogen oxides and other gases from your tailpipe. Okay. Now, because these things are in place, we're very lucky that the air quality of most of our cities, it's improving, but we can't say that's the case for everywhere in the world. And I found this really kind of encouraging when I'm looking at these statistics from 1990 of all these wonderful dramatic decreases in these air polluting substances. So we can do it. It can be done. And I thought this was, something nice to kind of include to show that we have made a lot of progress. The worst air pollution, not surprisingly, is found in developing countries. So you can see the areas in red have the most significant air pollution. Believe it or not, the Americas actually have some of the least air pollution. So we have some good quality air. The difficulty is, though, air pollution doesn't just stay in one place. Some of it stays local, but eventually what anyone's putting up, everyone's going to be exposed to. So that's one of the challenges we have in managing it. Air pollution was sometimes known as a silent killer because you don't ever think of someone dying directly from air pollution. It's more indirect exposure over many years. And we estimate about 7 million people to die from exposure to air pollution. As we can see here, most of them are from Asia, Europe, Africa, etc. Very few, thankfully, from the Americas. But it is something, environmentalists are concerned about. So what effects does acid rain have that, we need to be aware of? Well, organisms can only tolerate certain levels of acidity. If we're looking at perhaps a lake, and here's all of our organisms, frogs can withstand the greatest variation of acidity, but things like clams and snails cannot. Main reason it's these two that die quickly is because their shells are made of calcium carbonate, and acid is going to quickly weaken those shells and therefore kill these organisms quickly. Acid rain can result in the sterilization of lakes and forests. It can result in a large reduction in the populations of small invertebrates, like we just said, the clams and snails, and decomposers. It can reduce our agricultural yields. It can cause extensive structural damage because it reacts with the marble, metal, and stone. It can degrade our freshwater supply, and I think this is a really important and very concerning consequence of acid rain. As that acidic water percolates down through the soil, it's actually going to kind of leach these heavy metals and drag them along with it down into our groundwater supply, which that's how we get our water here. And lastly, it can increase human health issues like lung cancer. Here's some visuals. So here we have a fir tree that is affected by acid rain. So you can see it's not very healthy looking. It's not nice and green compared to the regular one. Here's a statue of George Washington before and then after years of exposure to acid rain. So if it can do this to George Washington's face, it can certainly do that to any building made of stone, marble, etc. In Australia, this was actually done. This lake had become acidified from acid rain, so they're actually dropping lime. into it so that they can kind of neutralize that acid. And then lastly, here's another effect of acid rain. We have the Taj Mahal before and then after many, many years of industry and air pollutants going up into the atmosphere. You can see the marble looks completely different, okay? And there's a significant haze in the sky. So how can we prevent acid rain? Well, if it's caused by fossil fuels, the only way to prevent it is to decrease our burning of fossil fuels. Instead, we have to have somewhere to get our energy from, so we need to increase the use and production of our renewable energy sources. And remember, we talked back in the fall, biomass, solar, wind, hydropower, and geothermal are the ones we're talking about. That's just good in general, right? Because these are renewable and we're going to have to move to them eventually sometime. Let's get our notes on acid rain. So we're going to define acid rain as precipitation that is made acidic, so pH around 4, by the burning of fossil fuels. We're going to remember that it's sulfur and nitrogen oxides that form sulfuric and nitric acids, because that's a nice bit of chemistry to remember there. And just for reference, pure water has a pH of 7. Some of the consequences, or what can result from acid rain: sterilization of lakes and forests, decreased crop yields, structural damage, pollution of groundwater by leaching of metals from soils, and human health issues. It can be prevented by decreasing fossil fuel combustion and using renewable energy sources instead, like solar, wind, etc.